So example 2 is very similar to example 1. What should we start by doing? We mentioned always drawing our triangle. And because they told me it's a right triangle, I'll call that angle C, call this one A, call this one B, just to mix it up. And therefore this would be little a, little b, and little c opposite the angle that creates it. And then let's label the parts that they gave us. So since they gave us two sides of a right triangle, how can we find the third? Let's start by finding little c. Well, notice that is the hypotenuse of a right triangle, which means we can then find little c by using the Pythagorean theorem, which says a squared plus b squared equals c squared. And since they gave us what our a is and b, we can then square those, add them together, and then take the square root to get what c is. So doing that in my calculator, you should have gotten that. Now, don't forget, we're not going to give them all of that for our answers. We're only going to supply them with however many significant figures that they have given us. And since this one had 4 and this one had 4, then we can supply them with 4. So we're going to look at the fifth and keep it as 71.27. Don't forget, since this would have been centimeters and this would have been centimeters, we know that this is also going to be in centimeters. So we got our side length, the only one that we were missing, in order to solve this right triangle pretty easily. Pythagorean theorem, applied that, boom, we're done. But what about the angles? How are we going to find the angles of these, since the only one they gave us was the right angle? Give you a second to think about that. All right, what did you come up with? What do we know, let's say, start alphabetically again, about angle A? Well, since we do know those are complementary, we only need to find one of them, and then we can subtract the other from 90, and that would give us the one that we didn't find. So if we're trying to find angle A, I need to somehow use these sides of this right triangle. Remember, we like to use the given sides rather than the one that we found, just in case we made a mistake. We can at least get this correct. And since we know from this the side opposite and the side that's adjacent to this, I know that I should be using tangent for that angle A to get the opposite over the adjacent. And remember, we can always take and cancel our like terms, but keep in mind what we're trying to do. We're trying to solve for angle A. And so as we learned in the previous section, in order to do that, we need to take the ratio that they gave us and reverse the input and output. And in order to do that, we're going to have to take this tangent function and we're going to put the little -1 to do the reverse. And that will give us this big old nasty number, 44.25 over 55.87 is equal to now my angle A. And that's what I wanted to get by itself. So all I have to do is punch that in my calculator, and that gives me a result of 38.3798 ... Again, only giving them the number of significant figures that they gave us, which was 4 in each. So we are going to have to look at the fifth, 1, 2, 3, 4, 5, which means we're definitely going to be rounding up to 38.38. And what would our units be? Well, because we're finding inverse, remember that's going to give us an angle, and in this case, it's in degrees. So at this point, you now have a choice. You can either take the 90 degrees and subtract the 38.38 degrees that we just found angle A was, and that will give you angle B. Or you can do something similar with angle B and then do opposite over adjacent for tangent this time. So I'll show you both ways just so that you can check and be sure that this does indeed work either way. So again, I'll borrow here and put 89 degrees and then put 10 there, borrow from that and put a 10 there. So now I have my decimals, 0.62 degrees, and then 89 minus 38 is 1 and 5. So we know that's what we should get out if we do this correctly, which remember the only thing we have to do for that is rewrite in reverse order, which we call the inverse in trig, inverse tan of that 55.87 over 44.25 this time. And that will give me my angle B, which we know should be this. Just confirm that in your calculator and then answer it whatever way seems best to you. And you should have confirmed that it was indeed 51.62 if you did this in your calculator. So solving these, again, can look a lot uglier than it actually is. So just be careful, be nice, neat, and organized. Make sure you don't get lost, lose your units, significant digits, or anything of that nature. So this third example actually looks a lot more like a word problem than the other ones that we've been doing. This one says the angle of elevation from a point on the ground 15.5 meters from the base of the tree to the top of the tree is 60.4 degrees. Find the height of the tree. So what I like to do is read the whole thing first. Now I'm going to go and try to figure out how I can draw this and then put in all of the things that they gave me to work with in order to find that height of the tree. I always like to read the whole thing first because now I know what I'm looking for, the height of a tree. So when drawing this, I know that I was given an angle of elevation from some point on the ground 15.5 meters from the base of that tree. So when I go to draw this, I'm going to start with that line. And the angle of elevation, remember, from some point is going to be looking up to this tree. And they said that angle of elevation from some point on the ground, which was this, from the base of the tree was a distance of 15.5 meters. Talking sig figs, that's 3 right there. And it said that angle of elevation from that point on the ground to the top of the tree is 60.4 degrees angle of elevation to the top. To find the height, that would be this. Call it X, call it H, call it whatever you want. So there's our drawing that we've set up. Now we need to set up an equation using the things that they gave us in order to find the thing that they asked us to find, which is H. So since I know this angle and I want this side and I was given this side, I'm looking at this as a right triangle because most trees do grow straight up and down. There's my triangle, and therefore, since I have the opposite and adjacent sides, I again am going to utilize my tangent function of that angle to equal the opposite over the adjacent. Now for this, it's pretty easy to solve because my H is on top. So to undo the dividing, I will multiply. Not top and bottom, but both sides to keep it equal by that 15.5 meters. So what I'm going to do first is multiply the tangent of 60.4 value I'll find, and then multiply it by that 15.5. So doing that, I should have gotten 27.2849 and so on. But because we only have 3 significant digits in each of these, I will then look at the fourth and make my decision on how to round that. So the height of this tree would be 27.3 what? In this case, should have been meters still involved. So pretty neat that we can actually start from the base of a tree, walk away to a certain point, and then measure the angle that we look to the top of it in order to measure the height of it without having to try to climb all the way up or drop a rope or ribbon or something to try to figure that out. Simple trig to be able to find that. Okay? Hopefully that makes sense. Pretty straightforward. Just be careful with your drawing and setting it up, both labeling it correctly and then your equation, and then solving with the correct number of sig figs. So the fourth and final example that I wanted to go over with you all is very similar to the previous. So I'm going to ask you to go ahead and pause it and see if you can do it from start to finish, and then I'll come back with you and walk you through it. All right, hopefully you're able to do that on your own. I'm going to start by doing my drawing, since I already read through the whole thing and knew I was dealing with an angle of depression from the top of a 97-foot building. Keyword there being from. And then it was to the base of a building across the street, which was located 42 feet away. So drawing this, I know I'm dealing with two buildings. There's my drawing. Definitely right angles with our buildings. And it said the angle of depression, meaning we know that we're facing in the downwards direction, depression, from the top of a 97-foot building to the base of a building across the street, which was located 42 feet away. So the cool thing is your drawing does not have to be drawn to scale. The math will take care of it. But be careful. What are we dealing with here? What do they want us to find? Usually they'll flat out tell you, and that was at the very beginning, they want us to actually find the angle of depression. Now this is where a lot of students will make the mistake. They'll go through this, they're like, oh, okay, I got it, I'm getting it. It's this angle right here, and I know the opposite and adjacent. I'm using tangent again. But because I'm trying to find the angle, I'm gonna have to do the inverse. Yeah, I'm getting trig. And then I gotta bring you back to reality just a touch. Because remember at the very beginning of this section, we talked about the angle of elevation or depression being from a horizontal line, that line of sight. So if we are at this point, that's going to be here. That's going to be our line of sight, that horizontal. So the angle of depression is actually going to be that angle, not the one that a lot of you would have found and unfortunately gotten wrong. So if you did that, I apologize, but hopefully you did make the mistake. So now you know and you'll never make it again. But if you do also recognize that this is a horizontal line and this is a horizontal line, and at the very beginning of this class, when we were reviewing a bit of geometry, we talked about two horizontal lines being cut by a transversal. And this angle right here being very similar to this angle right here, actually called alternate to my transversal, interior to my two parallel lines. So these are indeed what are called alternate interior angles. And so we can use this angle, not that one that many of you probably found if you tried it yourself first. Okay, so be careful with that. Yes, you were right. We are going to use tangent of that angle theta, but I'm going to use it here. So the opposite is going to be 97. The adjacent would be 42. And a lot of you, unfortunately, probably had that reversed, which the reciprocal would be cotangent. Okay, so be careful. Lots going on here. To flip-flop these and get the angle by itself for this tangent, we would have to do the inverse in order to reverse our input and output. So all you have left to do is punch that in your calculator, and then don't forget to give me the correct significant digits or figures for this angle of depression that we're finding. Okay, so hopefully you got the answer of 66.58788, blah, 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 blah. And then since they gave us two significant figures, we can only give them two, which means we'll look at the third, and you should have rounded this to an angle of depression of 67 degrees. All right. So again, be very careful. Most importantly, drawing it and then setting it up with the proper placement of either your angles or sides. And then from there, creating equations with the given things. And then lastly, supplying them with the solutions or answers according to the least number of significant figures that they gave you in the entire problem. Okay? Keep plugging away, keep practicing. If you need more practice, keep doing more examples, or go and tap into the e-text and work through that, or on the quizzes and study guides. Guys, have a great one. I'll see you at the next episode.